Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 23, Stoichiometry Part 4. Here are our objectives for today's video. Pause here. So in order to actually bridge what we've done before, which was not exactly stoichiometry, to actually be stoichiometry, we need to throw chemical equations into the mix. So we're going to need to understand how to write them and how to balance them. So just some general terminology. So on the left of the arrow, those are the reactants, and on the right of the arrow, those are the products. Everything that is present in the reactants must be present in the products, both in terms of what atoms and how many atoms. And then some chemical equations, but not all, are going to include the state of the chemicals. So an S in parentheses means that it is in a solid state. An L in parentheses means that it is in a liquid state. G for gas. And aqueous, which means dissolved in water, is AQ. Pause here. So when we are balancing a chemical equation, this is very, very, very important. You cannot ever change the subscripts. You cannot change what chemicals are there. The only thing you can change is the coefficient, a coefficient being the number that goes in front. There's not really a big methodology to balancing chemical equations. I'm going to talk you through a couple of these, but it really is guess and check, and some of them are just easier than others. Pause here. Right, I'm going to walk through this with you, just showing you my sort of strategies that I'm using. But again, it really is just guess and check. The first strategy that you could use would be to just start with your most complex molecule. But that's just one strategy that often works, but does not always work. One thing I see is that on my left, I've got 2 hydrogens, and on my right, I've got 1, 2, 3. No matter how many there end up being, I have to have, if it's even on my left side, it's going to have to be even on my right side. So I put a 2 here. But then in doing that, I have 2 potassium. So I need to fix that by putting a 2 here. Then I have another problem. I've got 1, 2, 3, 4 hydrogens from here. So I just put a 2 there to balance it. And then it looks like everything checks out. So one thing that I like to do, at least when for like the harder type of questions, is that we can make a sort of table just to help us figure out if we did the answer correct or not. So you can make a little table, and it doesn't have to be big, and I just list all of the elements that are in the problem. So in my reactant, I've got 1, 2 potassiums. I've got 4 plus 2, 6 oxygens, because 2 times 2 is 4. I multiply them, and 2 times 1 is 2. And then I have 2 times 2, 4 hydrogens. Then in my product, I've got 2 potassiums. I've got 2 plus 2 plus 2 is 6 oxygens. And I have 2 plus 2 is 4 hydrogens. So if your numbers on the reactants and the products are the same, you know that your answer is correct. Okay, let's take a look at some other ones. So I'm going to start by looking at CH4, just because it has the highest subscript. I could have picked something else. My carbons look balanced, but my hydrogens are not. So I put a 2 here to balance that out. Now I need to worry about my oxygen, since both my carbons and my hydrogens are fine. I have 1, 2, 3, 4 oxygens over here. So I need to have 4 over here. That is why I put a 2 there. And now for my next one, I'm going to start with my Cr2s3, and I'm going to specifically start with the sulfur. I've got 3 sulfurs over here and 8 over here. So the lowest common factor is 24. So I'm going to make them both 24 by putting an 8 here and a 3 there. But then that means I've got 8 times 2, 16 chromiums on my right. So I have to put 16 on my left, and there, this is now finished. Pause here. All right, so there are certain elements that when they are in the gas phase, they form diatomic molecules, meaning they bond with themselves. This will be important when we're doing problems where instead of given the unbalanced chemical equation, you're giving something in words. So if it says oxygen gas, that means it's O2. I'll list them all out. And this only applies when they are elements, meaning that they're not bonded to something else, and when they're at room temperature and regular pressure. Otherwise, you'd have to have a little bit more information. Some students like to use the expression Hunkelbrief to help them remember which ones are diatomic. Just note that none of these are noble gases. Right, that is all for tonight's video. Thank you so much for watching and have a great night.